Okay, can't always be used, but we can use it if f can be differentiated repeatedly to become 0. In other words, an example would be a polynomial, right? If you keep differentiating it, eventually you'll get to 0, right? So that's it, like, so an example is a polynomial. And the other part, g, has to be integrated without difficulty, repeatedly. So an example would be e to the x, or, right, so e to the x or cosine x, right, because they'll just keep flip-flop. Okay. So what we're going to do, so remember this one? We did this one already.
Wait, for the g repeatedly, is that like infinitely, just like kept on?
If you kept going.
Oh, okay.
Yeah, so we could keep going. So what we're going to do is we're going to make x squared, that's going to be our f of x. And then g of x is our e to the x. Okay. Oh, sure. Sorry. Oh, there's like stuff on the boards. Now, I don't know if you remember, this took 2 steps of integration by parts. Now, let's see how long it takes. Okay. So we start with x squared. We're going to do the derivatives here until we get to 0. So 2x, 2, 0. Right? So keep in mind any kind of polynomial, because when we keep doing, right, eventually we'll get to a constant, and then eventually we'll get to 0. On the right side, what are all these going to be? Just e to the x. Okay, now we're going to draw arrows down to the right. So it's going to go, so don't go straight across. It's going to go from this x squared, although it doesn't really matter because the right column is all the same. Good. Okay. Now it's going to go plus, minus, plus.
Always plus, minus, plus.
Always plus, minus, plus, minus, plus, plus. Yeah. Always starting with plus. So this is equal to x squared times e to the x minus 2x times e to the x plus 2 times e to the x.
That's crazy. Wow. Plus c.
Plus c. And that's it. That's the tabular method.
That's
So compare
really
that to this one. It's the same exact problem done with tabular method.
That's really cool.
Right? Okay. How many steps are we going to have will depend on the exponent here.
How many derivatives?
Yeah, so how many derivatives it takes to get to 0. So if you look at the next one, I have x cubed, so how many?
Take one more.
It's going to be 1 more to get to 0. But can you imagine how long this would take? Take a long time. So I have x cubed is my f of x, and sine. The hardest thing here is not messing up this plus and the minuses. Okay.
If it's more than 3, then does it just keep alternating?
Yep, it just keeps going. So 3x squared, 6x, 6, and 0. And then working backwards on the right side. Don't forget, these are the derivatives, and on the right side are integrals. So the integral is negative cosine x, then negative sine x, then cosine x, then sine x. plus minus plus minus. Did you get it?
X cosine x, or x cubed cosine x plus
Yeah.
3x squared sine squared cosine x.
All right, so let's check, did we get all the signs correct? So the first one is going to be
Negative.
negative x cubed cosine x. Next one's going to be
3x squared sine x.
good, plus 3x squared sine x
And positive.
plus
Plus
6x cosine x
Wait, what? Wait.
minus 6 sine x plus c.
The derivative of sine x? I thought it was just go.
No, integrals.
Oh, wait.
Yeah. What? I missed that.
No, nothing.
Integrals. So we're working backwards, integrating on this side, but we're doing derivatives this way. That's why I said that's the biggest mistake that I see, is that we mix up like the positive negative. Good. So that was tabular method.
Easy peasy.
That's
Okay.
really cool.
Oh, do we need to?
Inverse.
Okay. Inverse trig and logarithmic functions. Okay. All right. We have not integrated natural log of x. Don't get that confused with the integral of 1 over x, which gives us natural log of x, absolute value. But we can use integration by parts to integrate this. What do you think? Think back to
Logarithm.
so we're gonna make
Logarithm.
U equal to ln of x.
And d
Just dx.
dv is gonna be dx. Okay. Now there's a reason I can't use tabular method here.
Because then you have to integrate.
Could you use tabular method here? No, because there's no way I could take the derivative of the natural log and get to 0, right? It'll be 1 over x, negative
Oh,
1
yeah.
over x cubed, and so on.
Oh,
So
yeah.
that's why we're not going to use tabular method here. All right, so du is going to be 1 over x dx, and v is equal to x. So uv minus the integral of v du. So uv, I'm going to put the x in front, minus the integral of v du. Good? Yes. One thing I'm just going to add in here, though, I'm going to put in absolute value around the natural log. So x, natural log of x plus c. All right, because you're just integrating 1. Yeah. So that's actually the rule for the integral of natural log of x. Some teachers just have you memorize that one, but you could easily just do it with integration by parts.
Why is it
Plus
minus
minus.
x? Isn't it minus
Yeah.
x?
Oh, thank you. I missed the minus sign.
Thank you, Max.
See, that's what happens when I'm not. I don't have. Good catch. No. Okay.
Every time I say something that's good, they say I'm just yapping.
You said it yourself.
I do yap a little bit.
Okay. Last example, and then we could tackle some of the homework. So we have dy dx. So I'm just going to move the dx over. And this one is I'm actually going to solve because it's going to pass through the point 0, 0. Good. So we're going to do the same thing. So we're going to use the integration by parts. U is our inverse.
And what is dv?
dx.
And dv is dx. Remember the derivative for sine inverse?
1 over root 1 plus.
No, 1 not. No.
1 minus x squared
Plus x.
dx, and v is equal to x.
Everybody's lost.
So y equals uv minus the integral of v du.
Did you use U substitution?
Gotta use a u substitution. Now we have a new u again. What's wrong? Which part? Are we okay? So our new u is equal to 1 minus x squared, which makes du negative 2x dx. Can pull out that negative 1/2. Did we get it?
I think so. I didn't plug in yet though, so they plug it in.
Did we get, oh, I didn't get the final answer. I was just wondering if this is, if that's what you got.
Yeah, that's what I got.
There we go.
Yeah.
C was -1. Oh, you didn't get it.
What did we get? Now we have to plug back in for, well, that's easy, because we plug in 0, that's gonna go away.
Just 1.
This is just gonna be 1.
So it's -1.
So C is -1. And that is the rest of 7.3.
Give it up.
Look at that, with 31 minutes to spare.
Left to spare.
So now you